WordPress, but we're also branching into JavaScript, which is why I wanted to come to Brazil and meet a bunch of amazing developers who work with JavaScript. So when we have lunch after this talk, come and talk to me. I'd love to learn more about what you're doing, and now I'm going to talk about some cool things that I do with JavaScript. Shakespeare is one of my favorite writers. This past week was actually his birthday. Thankfully, he's not alive because he would be incredibly ancient and probably not fun to talk to. But one of the best pieces of writing, in my opinion at least, was his play Hamlet. One of my favorite lines is Hamlet's soliloquy. To be or not to be, that is the question, whether 'tis nobler in the mind to suffer the slings and arrows of outrageous fortune, or to take arms against a sea of troubles, and by opposing in them. I think it's really great. It's a kind of writing that I would personally love to be able to do, but I can't quite get there. So somebody once told me about something called the million monkey problem, or the infinite monkey theorem. It's the idea that you can have an infinite number of monkeys typing on an infinite number of typewriters, and eventually, unlike me, they will be able to write Shakespeare. So I figured that would be kind of fun to play with, but unfortunately, as people have had more experience with the internet, they've seen that having a million people typing on a million typewriters won't quite produce Shakespeare. So obviously there is something broken in the setup. So I figured I would abandon conventional thought and try to run this on my own and try to come up with my own way to have a million monkeys trying to type Shakespeare. I did some research, and it turns out that monkeys are quite expensive, and the typewriters are expensive too, so having a room full of monkeys and typewriters was just prohibitive. It wasn't something that was going to happen. So unfortunately, the cute little monkey doesn't get to have a typewriter. He doesn't get to try to write Shakespeare, so I came up with a better solution. Instead, we're going to create virtual monkeys in JavaScript. When you take some time to think about how this is going to work, we're actually going to deal with a genetic algorithm, which I'm not going to go into too much detail about, but essentially it will create a digital monkey and tell the monkey, try to write Shakespeare. Then it's going to take all of these monkeys, a huge room full of monkeys, and rate them. Which ones were really close to writing Shakespeare, which ones were not. The ones that were really close to writing Shakespeare, they get to make little monkeys and create the next generation of monkeys. The ones that were really way off, we just get rid of them. We don't want to deal with them. They can go back to the zoo. And we're going to do this several times, several thousand times, until we can produce a digital monkey who can type Shakespeare. So the first way that we tried to do this with monkeys v1, it's pretty basic, pretty simple script. This is kind of pseudocode. It's not functional JavaScript, so don't worry about trying to run it. It's just to give you an outline of how the code might work. First, we're going to create a random generation of monkeys. We're just going to grab about 200 monkeys at random, give them typewriters, and say, try to write Shakespeare. If any of them actually write Shakespeare, we say we're done. And we move on. We've accomplished our task. We have a monkey who can write Shakespeare. We can move on and release millions of unreleased plays and make a lot of money. If they can't type Shakespeare, then we select the best monkeys, the ones that were the closest to writing Shakespeare, to create the next generation. We allow them to create the next generation of monkeys, and then we test again, and again, and again, about 5,000 times before the monkeys are actually going to be able to create Shakespeare. It takes a long time. It's not going to happen overnight. There are problems with this code if you were to try to write it this way. Namely, it's going to make your computer explode, so don't do it. When you write this code, you have to remember that the web browser is single-threaded. Only one process runs at a time, and it runs from beginning to end. If you write this code and it loops thousands of times, you now have thousands of lines of JavaScript running on your machine. That code by itself would take over 2 hours to run on a brand new MacBook Pro. So it's not going to be anything that's done very quickly. Now, if you have a JavaScript file in your browser that takes 2 hours to run, your browser is going to stop. It's going to freeze. You're going to get an error message like the one below that basically says the page has become non-responsive. I can't do anything with this page. Do you want to just kill it? So the monkeys never type Shakespeare. Nobody's happy. And we just kind of sit there and we haven't solved the million monkey problem. So let's go ahead and rewrite the code. Let's try to break things up a little bit. Monkeys v2 is going to do a lot of similar things, except now we're going to wrap some of the functions in just a utility function. So once again, we create our random population, and then we have a function defined called create next generation. Inside this function, we select the parents, the ones who were close to typing Shakespeare, and we let them breed to create the next generation. If they can write Hamlet, they can write Shakespeare, they're smart enough, we're done. We finished our project. If they aren't, then we use set timeout to basically wait 10 milliseconds and actually allow the browser to process other tasks, actually allow the browser to continue running. And then we just call create next generation again, and again, and again. Just like the previous example, this is going to have to iterate about 5,000 times to actually create monkeys who can type Shakespeare. Not very performant. I mean, it's got some issues, but it will actually work. That code will run. The monkeys will be able to type Shakespeare. It takes between 5,000 and 6,000 generations of monkeys and runs between an hour and a half to 2 hours on a modern computer. So it's still not very performant. It's not very useful. And if you were to try to run this in production code that you were to give to a client or a customer, they would not be very happy with you. The reasons are because, once again, the browser is single-threaded. Now, to give you an idea of what that means, my computer has 4 CPUs inside the computer. Chrome, the browser that this is running in, can only use 1 CPU. It just sits there, runs with 1 CPU. The other 3 don't do anything. They just sit there, they're completely idle. So we're running 5,000 generations of monkeys on 1 CPU inside the computer when we have 4 available. It would be a lot more efficient if we could use all 4. But inside Chrome natively, you can't. So because of that, it takes a long time. It's not optimized for your hardware. I talked to a guy who had a 12-core machine, which is 3 times what my computer is, and he can run the code demo I'm going to show you in a couple of minutes in about a minute. Remember, 2 hours is what it would take with the single-threaded version. He ran a different version of the code in a minute on his computer because we're going to rewrite it to make it more highly optimized. What we're going to do is we're going to use an HTML web worker. This is a newer API that was introduced in HTML5 that allows you to spin up a separate process on your machine to run code. So in addition to the main CPU core that is running your Chrome browser, the UI, all of your plugins, you can create another application, another instance that runs in the background and run your code there. There's no limit to the number of web workers you can have. So you could have 3 web workers, and now with my 4-core machine, I have 1 core managing the application and 3 cores, each with their own independent web worker, crunching data and allowing monkeys to go out and attempt to type Shakespeare. So this is how our application would look. We would create our random population. We have an array of workers that we're going to use. And for each worker, we tell that worker to try to spawn the next generation. And then once all of the workers are done, we say we're done. This runs transparently in the background. It doesn't interfere with anything on your application. It will not crash your browser. It's quite performant. And as you can see, possibly from the screenshot at the bottom, I had a coworker run this on his Mac just to prove it wasn't a works for me situation. And you can actually see over here on the right that Google Chrome was using 282% of his processor, which means it was using more than 1 core. When you have a multiple core machine, you can actually use 300, 400, 500% of your computer's available processing power. He was using almost 300% of his processing power when he was running the multi-threaded application. When he ran the earlier version, Monkeys v2, he only used 85% of his processor. This is incredibly more performant and incredibly faster. So what we're going to do, now that we figured out how we're going to actually build the solution, is I'm going to take you through a short walkthrough of how the code actually functions. I tweeted out some links right before I started speaking that have links both to the slides on GitHub and to the code demo on GitHub. I'm not going to go too deep into things like the genetic algorithms. If you want to, it's fully documented on GitHub. Feel free to take a look, download it onto your own machine, test it out. It's pretty cool. I'm going to explain to you some of the components that we need, some background information on web workers, some background information on promises, because both are necessary for this application. And then I'm going to show you the different scripts that are involved. And then at the end, I'm actually going to run the demonstration so you can see how we can create virtual monkeys in JavaScript who can also write Shakespeare. Who has used a web worker before in an application? Okay, a couple of hands. For those of you who don't know, like I said, a web worker is a new process in JavaScript. When you are building an application, you have the JavaScript virtual machine that is inside the browser that runs everything. One of the reasons people say certain things in JavaScript are insecure is because every plugin you have in your browser can talk to this JavaScript virtual machine. You have a global scope. Anybody who has not used the var keyword to define a variable has polluted the global scope. And you now have all of this creep inside your application that is going to corrupt data and make things a little bit messier to work with. When you're dealing with a web worker, it's a brand new context. It's a separate process on your machine. You have Chrome that is running the browser, running the window, rendering images, rendering your page. And then you have a completely separate process that's also Chrome that sits alongside that runs your web worker. The advantage, you have a completely new scope, no variable creep, no pollution. The disadvantage, you don't have access to everything that the main thread has access to, namely the DOM. There is no DOM access whatsoever inside a web worker. So if you use a web worker and you want to change the color on a page, or you want to change markup on a page or add elements, the web worker can't do that. It can do data calculations and figure out what instructions the browser needs to have, and then pass that back to the browser. The browser can take care of it for you. So it's just one thing you need to remember. Anything that happens in the worker happens in the background and can't affect the page in any way. You need to send instructions back to the main parent application to have it take care of those instructional changes. The other foundational thing we need to talk about are promises. Promises in JavaScript are ways to defer an event and have basically chain callbacks together. So if who here has worked with jQuery in JavaScript, or just with AJAX calls in general? When you have an AJAX call, when you have something asynchronous, you wait until it comes back and then you do something in response. If you've worked with jQuery's AJAX, it is actually implementing a promise. It's implementing a deferred. So if you have, some applications will make several AJAX calls to actually build a page or to build an application. You can actually use jQuery's promises library, its deferreds library, to chain these events together. And so you can say when all 12 of the AJAX calls have completed, then I want you to do something else. We're going to do something very similar. We're going to schedule our web workers to run in the background, but we're going to wrap them in a promise so that we can say when all of these workers have finished doing their job, when they're all done, then we're going to move on and do the next step. It's a lot cleaner than trying to check, is this worker done, is this worker done, is this worker done? You just wrap them all in promises and the workers can tell you when they're done, so you don't need to worry about checking the state of each worker independently. The first script we have is our genetic algorithm. This is one of the basic scripts we have. This is what we have that's going to represent a monkey. Essentially what we do is we tell the genome object, we're going to give it a text, which is a random string of characters that the monkey has mashed into a keyboard. So he's just sitting there typing away. You have a string of characters, absolute gibberish. We don't really care what it says. We just want to compare it to a target text, which is our Shakespearean line, to be or not to be. Inside the function, we have the ability to compute the fitness of the monkey. So we can actually rate the monkey. How well did this monkey do? How close did this monkey come to writing Shakespeare? If the monkey wrote Shakespeare really well, it's going to have a fitness of 0. We want the fitness to decrease. A really unhealthy monkey will have a really high fitness, which means they're completely off base. They've never read Shakespeare. They're trying to write something else, probably a JavaScript spec. It doesn't make any sense, so we really don't want to have to read it. So instead, we're going to get rid of that monkey and take one that can write Shakespeare, which is something we do want to read. The monkey itself internally has a bunch of getters and setters defined. These are just to allow us to access and set properties like text and target text, and then automatically recompute the monkey's fitness after we change a value. If we decide to change the target text, we don't want to write Shakespeare anymore, we want to write James Joyce. We give it a new target text. The monkey will then automatically say, I have no idea what you're talking about, my fitness is really low. We don't have to manually recompute that. The next object we're going to deal with is a task runner. This is the workhorse of the script. This is the part of the application that does all of the heavy lifting. The task runner has an array of web workers that it's going to deal with, and then it keeps track of some static information. We know that we're on generation 1. We're breeding monkeys at a rate of 0 monkeys per second. We're starting at 0 seconds, and our population of monkeys is an empty array. When we run the task runner, we set up a jQuery deferred because we want to use promises to actually script our application. We, once again, reset the generation to 1, the rate to 0. The start is now in seconds so that we can calculate how many monkeys we're breeding each second to keep track of our simulation. And then we set up our web workers. If there are no workers, we need to create web workers. So we instantiate, in this case, 3. As I said, I have a 4-processor machine, so I'm trying to optimize for my hardware. You can have as many workers or as few workers as you want. Depending on the machine you're working with, you will need to optimize this independently. Some machines have better hardware than others, so a 3-core machine might be able to handle 12 web workers perfectly fine. Other ones might be able to handle fewer web workers. It depends on your use case and the hardware that you're actually running on. So take some time, play with numbers, and see how it works out. Our next function is actually what's going to run the next step. It's going to run the next generation. Internally, it calls a step function, which returns a deferred. We'll go into that in a second. But when the step function is complete, we're going to check and see, has the best monkey been returned? The most fit monkey. If the monkey has not been returned, we reject our deferred, we exit out of everything, and we basically say, the monkey's failed, they can't type Shakespeare, let's go do something else. If we do have the monkey, and the monkey has a fitness of 0, that means he typed Shakespeare. This is great, we're done. We're going to print our result to the screen, we're going to close everything out, and we're going to say we're finished. If the monkey couldn't type Shakespeare, we still want to notify and say that we've done some progress. So we're still going to say this is what the best monkey was able to type, this is the rate at which we're breeding monkeys, this is how many monkeys we've bred so far. And then, because the monkeys aren't done yet, we're going to up the generation count, we're going to calculate the rate at which we're breeding monkeys, and then we're going to call next again. This is an iteration, so we're going to do the next step, and then the next step, and move on and on. Our step function is what actually tells the workers to run. Inside the step function, we set up, once again, another deferred, because step needs to return a deferred so that we can schedule events, and we can actually deal with data as it comes back. We're going to set up an array of promises, which are going to wrap our worker objects. We're going to decide what our initial population is. This is where we take our 200 monkeys and we order them based on the ones that are the closest to writing Shakespeare and the worst, and we kill off the bad ones. And then we just take the good ones and let them create the next generation. For each of our workers, we set up a promise for each worker, and then we tell the worker what it's going to do. We're going to pass in data, which is the initial monkeys that we want to work with, and we're going to tell the worker, give me a pair of children. Take these 100 monkeys, grab 2 at random, and produce 2 children for me. It's going to go through, it's going to create those 2 children, and then return, which is going to resolve the promise. As we go through, if we still have jobs to do, we go back and we assign a new job to the worker. It comes back, we still have work to do, we assign a new job to the worker, and we keep doing this until we have built up a new population, a new generation of 200 monkeys, and then we can move on to the next step. This script is going to be the most interesting. This is actually our web worker. Now, unlike the previous scripts, all of our previous scripts run in the browser. The web worker script runs in a separate process. It's completely independent of all of the other code. So this worker doesn't use closures, it doesn't have anything wrapped because the global scope is completely empty when this worker is instantiated. So we set up a few global variables at the top with some probabilities for the genetic algorithms. We set up the population, which is going to be empty. We set up some other variables that we need to actually process the genetic algorithm. And then we set up an on-message event handler. When you send a message to a web worker, you're using post messages in HTML. So we're going to set up an on-message handler so that when the worker receives a message from its parent, it's going to act on that message. We have 2 possible things the worker can do. It can clean itself up, which means it's basically just going to shut everything down and stop running, or it can spawn 2 new monkeys based on an initial population. So this is just where we're checking which method is being invoked. And if we're creating children, we step through a genetic algorithm to actually process and create the children. Once again, this is something you can go through on your own if you're interested. All of the code is up on GitHub, and it is much more documented than it is on here. I had limited space in the slides. The main program script just basically ties everything together. There are some buttons on the page to tell the monkeys to start typing or to tell the monkeys to stop typing. So what we're going to do is we're actually going to wire up all of our event callbacks to see how the monkeys are working. When we're going to make the monkeys start typing, we instantiate our zookeeper, which is our task runner. We tell our task runner to create an initial population of 200 monkeys. So it's going to create 200 monkeys at random and just set them and get them ready to go. Then we tell it to run. As the task runner is running, it's attempting to breed new generations of monkeys who can type Shakespeare. Because inside the task runner, we're using the notify event for jQuery promises, we can set up a progress keeper. So as the task runner notifies us that it's made progress, we're updating the UI so that we know what's happening. We know what's going on inside of our application. And when the task runner is done, then we're done. We alert the user that we're completely finished. We close off all of our progress loops, and then we clean up our task runner. When we tell the task runner to clean up, it will independently tell all of its web workers to exit. It will clean up its global state and release all of the memory and CPU assets that you need back to the machine. So to give you an idea of how this works, I have a brief example here where the monkeys are going to attempt to type this block of Shakespeare text. Currently, it's not running, so there is no current value. Down here at the bottom, you'll be able to see what generation we're on and how many generations per second we're breeding. Now, because this block of text actually takes a while to run, I'm going to cut it down to just to be or not to be, that is the question. And now I'm going to queue our monkeys. So as this is running, we are breeding 200 monkeys per generation at a rate of 25 generations per second. That's a lot of monkeys trying to type Shakespeare. It's a lot faster than a room full of actual monkeys. As we breed the monkeys, we create a random text string, and then as we tell the task runner to give us a new generation of monkeys, it goes through, evaluates the monkeys, orders them from least fit to most fit, cuts the generation in half, and then says, okay, give me 2 children from this population of 100 monkeys. I'm going to run that again because that went way too fast. Okay, so it's going to grab 2 children. It's going to calculate a crossover probability, which is about 85%, and then perform some genetic crossover to actually have some variation within the next generation. Then it's going to calculate mutation. When it calculates mutation, it will either increment or decrement the character value of a random character in the string, and it keeps doing this iteratively until the monkeys can actually type to be or not to be. That is the question. So the applications for a system like this are actually pretty endless. I use it for trivial examples like breeding monkeys and doing genetic calculations. I've seen other people use this more specifically for doing image manipulation, because you might have some really sophisticated calculations that you need to do to, say, calculate the average color of a square on a screen. You can do that in the background. You don't have to do that in the foreground. Anything that you can do in parallel, anything that you can separate out and abstract away from your code, you can do in a web worker, put it into a parallel thread. It doesn't need to interrupt the UI. It can do its work just like an AJAX call. So imagine anything that you were doing in AJAX where you send data to the server does some processing and then returns data, you can do in a web worker. It's pretty much the same interaction. You send data to the web worker does its processing, returns it back to you. It doesn't halt any of the UI thread. Considering we just heard a lot about how to do things offline and focus on offline first, the idea of doing data processing offline in a web worker that is a separate thread, a separate process on your machine, really makes it so that you can completely decouple yourself from a web server. You don't need to have all of these expensive resources in the cloud when you have all of these resources available right here that are completely untapped by the majority of the development community. You can do image processing, you can do cryptography. I've seen live video processing, video masks added to running video in the background. The possibilities are really endless, and I would love to talk to any of you who have other ideas or just other questions during lunch. We have been running a little bit late, so I am going to close just a little bit early because I am hungry, and I'm sure you all are too. So thank you very much for paying attention. Like I said, everything's on GitHub. Feel free to take a look.